Okay, so now we're going to move on to just general discussions. And so we can pick up any topics at all that we talked about in the meeting, or even topics that were not covered that you think are important to bring up, such as data weighting and process variation, which we kind of skipped through a bit because we didn't have a dedicated session on those two. So does anyone want to start off with anything? So Nicholas, you're standing up to start us off, are you? Okay. Yeah, Nicholas. Yeah.
Perhaps an opportune moment to discuss the potential utility of a size-structured modeling approach for tunas, and just curious folks who had a chance to see my talk, what they thought about it.
Okay, that's a good topic to start off on. Does anyone want to comment on whether a size-structured model would be appropriate for tunas and if it has any advantages over the current age-structured models that we're using? So one of the things that we learned earlier on at the spatial modeling workshop was the issue with growth changing, being different among areas. And so if you moved fish in an age-structured model from one area to the next, the size of that fish would change unless you somehow modeled the age and length distribution, or maybe possibly growth cohorts if you had a good way of doing that. But moving directly to a size-structured model, you would overcome some of those issues. So it would seem as though that would be a good approach to go. The only issue that well, not the only, but one of the issues that you'd lose if you did that is you might lose the information from the growth equation with the age and length growth. I mean, you still have a growth transition matrix in the length-structured model, but there might be something in that age length data that you're losing in the size-structured model. So does anyone have any insight into that? Yeah, Carolina?
Not an insight, but just a question. How will we compute this size transition matrix? We will still have to use the age data, right? Outside.
Yeah, we could use it from the growth increment data. That's the standard approach in
the tagging data then?
Yeah, so the tagging growth increment data. So that's the standard approach in crustacean modeling, which is where most of these length structured models are applied. I actually have a growth paper for skipjack using just the growth increment data, and I also did a size structured models using that information for skipjack a few years ago, but I kind of didn't follow up on it because I didn't get anything out of it that was an improvement over my previous age structured modeling of skipjack. But even that model was not very good. So we've moved on since then. So it's possible that a size structured model for skipjack in the Eastern Pacific might actually be okay now, given some of the assumptions we're making with using the long line link frequency data and things like that.
Yeah, that's a good point that I was gonna touch. Like, we have too much sensitivity to the L infinity in our model. So will that be improved if we go size based? And since we're now having more tagging programs, at least us, maybe an option.
Yeah, just some simple comments. I think it seems make a lot of sense to at least try the size structure model for tuna, just to see how it performed. There seems to be a lot of good reasons for mention. For tuna, we're dealing with mostly length size structure data, and one of the advantages for using age-based model is to track in cohorts. And normally with those size data, we know from our discussion, they're quite, a lot of issues with quality and sampling noise. There's a lot of, quite often we discuss in tuna assessment is that we normally don't get much recruitment signals from those size data if there's any. Quite often we downweight those size data. So it seems to be a lot of good reasons to at least try out some of the size structure model, and especially we have those tagging data that's kind of readily available to estimate gross transition metrics. That doesn't seem to be a big deal as well. So, and also there's a lot of software there. It's capable of doing size structure model quite easily, like Castle, that can implement both age structure and size structure model. I think a good exercise would be just configure some kind of model in both age structure and size structure in those those kind of packages, just to make quick comparison. That would be a good starting point. I do see a lot of value to try it.
Okay, any other comments? No.
Can't we have both? I mean, is that working? Yeah, there we go. It's something we talked about a few years ago in this room, I think, as one of the things of next generation stock assessments was size versus what about size at age? I mean, most of the processes are size based, but some of them are age based. So that sort of leans towards, can you do both? I mean, it's not like you can't do it. You can write down the equations. The size transition matrix moves everything through the size classes, and an animal gets older 1 year to the next. I mean, it's adding an extra dimension, and it's not. There's some technical things you need to do with it, but it's considering some of the things we're thinking about doing with really detailed spatial models. I would have thought adding in size and age structure concurrently is well within our grasp.
Okay, thanks, Rick. Carolina, can you pass the microphone down to the...
Yeah, I basically have a same question. So I was just curious, like, why not like using both length and age structure model? Other than I don't know if there's any disadvantage of using it other than computational cost. But yeah, I also recently kind of used both length and age structure model for jack mackerel in New Zealand inshore fisheries. So yeah, it's quite complex and it takes some time. But if once we develop that kind of model, we can use both like length structured or either age structured. So yeah, I was just curious, like what kind of disadvantage we have other than computational cost.
Yeah. So I did hear a rumor that Dave Fournier had some great plan to produce a size structured model for tuna. I was wondering if any of the SPCs had any insight into that. Obviously, it's probably not going to be realized now that he's retired, but
just relayed discussions on this with Nick Davies, whose name was brought up in Ray's talk. Obviously has a lot of experience and has worked with lots of different model platforms over the years. And he was like Dave's offsider for the last 6 or 7 years and developing multifan. And when it come to the point of Dave considering whether to continue on or to retire, he said, if I was to continue on, I'm turning this into a length-based model, integrating age structure and tagging. So that's where he saw the need to go. So we listened to that with a fair bit of attention. And the last meeting I had with Nick, when we were discussing what's the future of our platform at SPC, we don't have the brains behind it. Nick doesn't have the mathematics skills that Dave had, and his opinion was that we need to start looking at the next model framework, and strongly recommended that we consider length-based models, given all the length processes going on in these fisheries. And I guess particularly coming from skipjack, where we really can't age those things with hard parts very well, and we're using tagging data and other things. So it's, one of the biggest fisheries in the world, and we don't probably have the right software platform to do assessments on them. So I think we've got to take it seriously that this is a type of assessment platform that we need, even if it's used in combination or comparison with other ones. So I'm pretty keen to see that to be explored seriously. And Simon mentioned that CASAL, and I'm not over all the software and what they can do, could potentially do this for us. So I think when we think about our transitioning in how we're going to do assessments at SPC, we are now at the point where we have to consider doing our assessments in multiple software, and you know, this spatial simulation project, this is the sort of thing we kind of need, I think, to be comparing the different softwares and going down that approach, because I don't know how the science committee is going to deal with this when we come at them and go, well, we've been using multifan for the last bazillion years, and pretty much assessments in the WCPO were built off that software, changing to another one, what the process will be. Is it okay to just repeat the same assessment in multiple software and present the alternative results? What happens if they come out a bit different? How do you deal with that? But I think this simulation project was an example of perhaps the way we need to go, but definitely support considering these length-based models.
Okay, thanks, Paul. Yeah, given Dave Fournier is one of the leaders in developing our software and assessment models, pioneer of the integrated analysis, we probably should listen to him to some degree. Okay, we've got an online one. Yes, Matt Vincent, do you have a question or a comment?
Yeah, I had two questions about the length-based model. So if you try to integrate tags into the model to estimate the growth transition, do you need to do something different in the likelihood so that, like, if you want to incorporate the tag data to estimate the growth and estimate the fishing mortality and all that stuff, do you have to somehow downweight the tag data so you're not using it twice, or because the length data is fundamentally different from the mortality component, do you need to separate those two? And then on a separate note, how do you deal with, there seems to be very high measurement variability or measurement error in the tagging data, and how do you incorporate that uncertainty into your estimate or deal with it in the models?
Yeah, good questions. Does anyone here have any comments on that? I don't see anyone, but I'm pretty sure the lobster and crab people have been dealing with all that. Maybe Jimmy and Ali or Rich might have a comment on that.
Yeah, I mean, in principle, the growth increment, I mean, you'd probably lose the ability to have that individual tag growth element that you would outside of the model. You're probably looking at how animals tagged in a given length bin transition through the sizes as they're recaptured. But that's going to really confound with how they're being selected and so on. So I think you needed some additional information if you wanted to do that, like the catch distribution or something like that, because you're probably asking a bit much of the tag data on its own to give you length and mortality. And yeah, as soon as you say length, mortality, and growth, mortality, and selectivity, I mean, you can't have all three with just one bit of data, I guess.
Yeah. The University of Washington has a general length structured model that they've been developing, which might be worth looking into. I'm not sure. It's designed for crabs, but it might be something that would be flexible enough to use for tunas. I don't know, but I guess Castle has a length structured model, but I'm not sure how it implements growth increments and tagging data and things like that. So something to investigate anyway. Okay, yeah, Dan.
Yeah, just on that, I think Castle's currently you have to put the growth, you have to fix the growth transition matrix parameter. You can't integrate tagging data in the lens-based model in Castle. Just clarification.
Okay, yeah, Simon.
Yeah, I think this would be looking at Castle 2 rather than Castle, and it's got a more sophisticated approach to tags than Castle.
Okay. Anything else anyone wants to talk about? Yeah, Haikon.
So we didn't spend a lot of time to discuss a data weighting in this workshop, and there was a presentation talking about how we should weight computation data. At least we have a few methods like self-weighting, for example, Dirichlet method, or tuning like Francis method. So I have one question for a colleague: how do you guys weight index abundance? Do you guys use like rooming square error, or just based on experience put a CV on the index abundance?
Okay, good question. Does anyone have any answers for that? I think that might be in our spreadsheet that we send around. Anyone want to comment? Okay, so I'll comment anyway. So there's multiple approaches that people have used in the past. One is arbitrarily putting it at a particular value. Sometimes we have individual estimates of CVs for each year, and often those are used either as a scalar or we estimate an additive constant on that. There's some people put smooth, some people estimate it, some people fix it, some people put a smoother through the index and use that as a CV. One thing that I haven't really tried it, but I think would be a pretty good idea is to fit your age-structured production model with recruitment devs to the index and use the CV that comes out of that, the estimated CV that comes out of that, because that would give you close to being the best fit to the model. So it would be a good smoother. Rather than arbitrarily doing a smoother through it, you're using a smoother that's based on the population dynamics. So that might be one way of doing it. Anyone else got any suggestions or comments for Haikon? Yeah, Nicola.
I have a related question, I guess.
Okay, go for it.
If you're trying to estimate your composition weights using self-scaling likelihood, like the Dirichlet multinomial, and in that process you find that you're substantially increasing the weight to your composition data at the trade-off of degrading your fit to your index, are there good practices or even just practices to, because I guess there's something about that data that is fundamentally being estimated to be higher than it maybe should. So yeah, I'm just wondering if people had thoughts on how to deal with that.
Yeah, so does anyone have any comments on that? Or maybe even more generally, how you should be modeling your length frequency data in terms of the likelihood and the weighting. I mean, there's the, basically, whether it's iterative or it is estimated as a parameter, there's a, it's kind of a little, I mean, they're basically the same, you just have to do it in a different way. The Francis method is based on average composition data, so average length for average age. So it takes the correlations into consideration, and generally has a lower weight than any of the multinomial-based methods. However, it doesn't work very well unless you've got lots of data, which I think Nicholas's simulation work has shown that, plus other people's work as well. Well, Nicholas can maybe. Yeah, but also you found that if there was model misspecification, the Francis method tend to do better if it had lots of years of data.
In particular, if the misspecification had a lot to do with the composition.
Yeah, and so basically misspecification probably is the most likely cause of correlation in your residuals, in your comp residuals. So if your model's not misspecified, the multinomial likelihood is probably the right likelihood to use anyway, or approximately. So my particular best practices or good practices is to use, to estimate the sample size outside the model, and that's your sampling variation. And then if you apply the Dirichlet multinomial and it changes the effective sample size in the model, that means you've got model misspecification. So fix your model misspecification until that effective sample size doesn't change that much. That's kind of my current thinking on the topic. Does anyone have any comments? Anyone think my methods are a lot of BS? Rich? Okay. You're laughing, you got to make a comment.
It wasn't laughing at the comment, just the openness with which you opened it up. I mean, I guess you could have a reasonable amount of process error that doesn't necessarily invalidate the likelihood, but its effect will be to reduce the overall sample size. But I'd probably on balance agree that most of the time it's just you're misspecified. I think if you did it alongside looking at the residuals, I think what you're saying makes a lot of sense. But there could be some points where you've just got genuine over dispersion in there, and that's what's bringing it down.
Okay, thanks. So just going through some of the methods that are used here for by different RFMOs for their Tuna assessments. Some use the Francis method, some fix it, some fix it at different values. Some use the Dirichlet, and yeah, so a wide range of ways of doing it. So obviously it's pretty much all the same data, same types of models. We should be doing it pretty much the same way, right? So definitely an area where we need to do some work to actually come to a good practice. And so I challenge anyone to improve on my good practice. Carolina.
So for the person, I think we have sort of like a good proxy that we can start, right? The wells, but I think we also need good practice for the long line type of data, because different fleets, they have different sampling programs, and they are not documented. So it's hard to figure out how to treat this data. So I guess even before the modeling, we should kind of strive to have metadata information that could help us even combine fleets that have different length frequencies, and even going as far as like do a work with the countries to sort of improve the sampling so it can be up to the standards that could pass some data diagnostic, let's say, to get into the assessment or things like that.
Okay, so one thing that we've been doing is for the long line data is the standardization of the composition data through the VAST approach, right? Which would produce estimates of the effective sample size. So how would what you're talking about integrate into that? Would the data that's going into the VAST model have to somehow be differently weighted? Something to consider.
But also, like, it could probably be a good idea to derive some data diagnosis, because if you see, like, okay, you put all the fleets in one vast model, and then you have runs of residuals by fleet or something. It will be easy to spot problems that you can then follow up, perhaps.
Okay, thanks. Any other comments on data weighting? We have data weighting for indices of abundance, which we kind of covered. We have weighting on composition data, again, which we covered. There is the fact of including the age data in there, so age conditioned on length usually, which has a similar weighting, but it's a bit more complicated, I guess. Then there's the tagging data. And we haven't talked about the weighting of the tagging data. And a lot of the ones I've seen, there's an over dispersion parameter of some kind that's used. But does anyone want to comment on that? Yeah, Dan?
It seems just from our experience, you can weight tagging data just through the over dispersion parameters or through the there's a lambda parameter for the overall likelihood. You can do it both. But it seems to, from our experience, the over dispersion parameter doesn't seems to change things much. I mean, another way is you can try to estimate in a model. It's a bit like estimating the CV for the CPU indices. It doesn't really work well unless you put a prior on it. Normally we just try different, try sensitivity of the different values for those over dispersion, but we find that it's not normally make too much of a difference.
Okay, yeah, Rich?
I'd probably offer a counterpoint there. I think it depends how much of a struggle you're having to fit the tag data. Like if it's estimating a really big one, it's because you're really struggling to fit it, or something else is going on. I mean, I know work with quite a few examples where you can estimate the over dispersion. It doesn't matter if it's Dirichlet multinomial or a negative binomial. It's a straight estimated parameter, and you can do. But I think that there are examples where you're not having too much of a struggle to fit the data. I think something like the yellowfin, when it's hard to fit that and everything else. I mean, over dispersion that's not where the problem is it? I mean, it's probably something else. So I think it is definitely possible. Like it's done for CCSPT and a few other things I work on, but I think it depends how well you fit in the tags.
Okay, thanks. Okay. So one of the things that came up in Andre's presentation on recruitment was coming up with some consistent assumptions or priors for some of the recruitment parameters, because those parameters, particularly steepness, but even some of the other parameters like autocorrelation and the variation of temporal variation in recruitment, particularly in the penalized likelihood context, we're not estimating them. So until we move to a true state space model, maybe we'll be fixing them, but everyone's fixing them at different levels. Some of them are on quarterly basis, some are on an annual basis, and they're fixed at the same level. There's also the spatial models that fix it on a couple of different components, the annual variation and also the variation in the proportion to each stock. So what do people think about coming up with some kind of common set of priors? Is that a good idea? And if it is, how are we going to go about doing that? I'll take no comments as the positive that we're going to all put our effort in to do it. Yeah, Nicholas, you have a comment?
Did Jim Thorson's old recruitment variation paper, did that cover the tunas? I remember he had a bunch of different taxonomic groups suggesting priors for recruitment variation.
Yeah, the problem with meta-analyses is it's based on data from somewhere, And depending on where that data comes, it depends on, it'll determine how good it is. So if you have something that's bad, I won't use the term that I should, and you put it all together, you get a pile of bad stuff. So you got to be very careful of meta-analysis. And for tunas like the steepness, probably the sigma R and things like that, it might be highly biased. So looking at, meta-analysis of that is probably not that good. But if we spend more time making sure that where we're getting those values from is more consistent and well developed, then yeah, it might work well. So I think it'd have to be a fairly comprehensive type of project to do it. Does anyone have any comments or any motivation to actually do something like that? No. So, okay. Something that needs to be discussed at a later date when we have funding, or maybe there's a student out there that will get motivated to do it and get some funding. So any other general comments? Yeah, Dan?
Maybe just a stupid question, just something out of my head. If it's wrong, just ignore it. Quite often, almost all Tuna thermal assessment produce those Kobe plots, right? The distribution of B over your reference point and F over your FMSY or other reference point. Generally, I think there's a perception that that if you do a grade or over the distribution over a large number of models, that kind of distribution is supposed to have a banana shape, right? If you get that, maybe it seems to say you're doing something sensible. If not, you kind of casting some doubts of your results. I just given the discussion we had with those model grade and ensembles, and I believe if you have lots of correlation among your models, you're supposed to get that sort of shape. But if not, you may get some other distributions. I just wonder if RFMOs have what their perception about whether that kind of your distribution of that your Kobe plots should kind of provide you with any information in terms of your final results and that kind of thing. Whether people are using that kind of distribution as a way to judge whether your model assessment is acceptable or not. Yeah, because this kind of discussion does happen in our meetings. Thank you.
Yeah, thanks, Dan. Anyone want to comment on that? No. Okay, so we've got scheduled for a coffee break coming up soon, so I think we'll break for that. And when we come back, I think I'll go through each of the topics, or at least the main topics in terms of model structure, and we'll talk about what we think is good practices for each of those topics, and we can get some opinions on whether or not they're good or not. Yeah, Arnie, you have a question?
Yeah, sorry, because your last question was whether we had a comment on Dan's comment. That was not the case. I have a different comment. And maybe one that's perfect for the coffee break as well, conversations. I think if we look back at this meeting 15 years from now, we might see it as naive, not addressing climate change very much, for speaking of funding. But if some of us will be modeling climate more explicitly in our stock assessments, let's say 10 years from now, which aspects would they be? I expect most, maybe not all, would be spatially explicit, sort of which processes and how would we go about it, I think would be something we could at least address a little bit in this workshop.
Okay, thanks, Arnie. Okay, let's break for coffee, which is not here yet. We'll break for coffee for half an hour, and it'll turn up pretty soon, hopefully.